Hello, beautiful people, and welcome. Today we're going to be graphing our sine function. Now, this sine function will have transformations in it, translations. So let's go ahead and get started. Before I dive into this form here, let's go ahead and graph our original parent function. So our parent function for graphing sine is, so parent is, let's call it, since I call this f of x, let's just call this, oh, I don't know, h of x. Usually the parent is the f of x and then the other ones, but it doesn't really matter. So h of x is equal to sine of x. So let's graph that. The way to graph is we're looking at our unit circle and we're looking at these points here. So we're looking at this point, we're looking at this point, we're looking at this point, and we're looking at this point. So we're going to be graphing one period. Now your instructor could tell you to graph multiple periods, and I'll show you how to do that as well. But in my class, I'm only going to ask you to graph one period. Just make sure that you put arrows because this is a continuous function. It never ends. One way to think about it is how many periods can you have when you're talking about the unit circle? Well, you can have an infinite amount of periods. So when you're graphing, the sine wave will continue in both directions infinitely. Okay, so here we have 1, 0. Here we have 0, 1. Here we have, what do we have? We have -1, 0. And here we have 0 and -1. So these points are important. Now the other points are also important, but we're gonna graph these four first. Okay, let's draw our x and y axis. Again, I am not a computer, so this is a rough sketch. If you want perfection, definitely go on desmos.com. I highly recommend Desmos. Type this in and it's going to give you the perfect sine wave. All right, since we're graphing, I'm graphing one period only. I know that one revolution, one rotation is 2 pi. Now, typically you do this in radians. When you're graphing, you typically do this in radians. You can do this in degrees. We're doing it in radians. So I know that my one full rotation is 2 pi. I know that this point right here is 0. Obviously, it's the origin. Let me actually write the origin 0 here. Okay, then we have, it looks like that's a point. It's not. I don't have white out in front of me, so ignore that. All right, so we have 2 pi. Half of a rotation is pi. Half of that rotation, or 1/4 of that rotation, is pi halves. And then this is where I like this trick. So if I know that, let's see if I have this size. So if I know that this distance right here is pi halves, so I'm just going to keep adding that. So this is 1 pi half, this is 2 pi half, this is 3 pi halves. So another way to think about it is take your one full length period, whatever that may be, because we are doing translations. So whatever your period ends, you take that and you can divide by 4, and that's going to give you this value here. But we'll, again, talk about that in a little bit. So like I said, these 4 are important. Since we're graphing sine, we want to focus on our sine value. Again, sine is in the y spot. So this is our sine, 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 and sine. So sine of 2 pi is 0. So that means sine of 0 is also 0. We have sine of 180, or sine of pi, is also 0. So far we have 3 points. Again, we are ignoring that one. So we have 3 points on our x-axis. Then we have our sine value of 1 for pi halves. There it is. So let's do 1 here. And we have a sine value of -1 at 3 pi halves. Let's go ahead and connect that. Now this is a sine wave. This is smooth. So I typically can't do that in one smooth curve, so I split it up the way that I just did. Now again, it is continuous, so it's going to continue up and it's going to continue down. So make sure you write your arrows. If you're in my class, you must have your arrows or else you will start to lose some points. It is continuous. Okay, things to know. Things to know about the sine wave. There are certain things. Okay, this line right here, yes, it is the x-axis on the parent line, excuse me, on the parent graph, but this is your midline. Okay, that's your midline. You need to notice that you have 3 points on your midline. You start on the midline, you end at the midline, and the middle is also on the midline. So you have 3 points on the midline. Then for a positive, a regular sine wave, in between your first and your middle point, you go up to 1, you go down to 1. Okay, that's the first thing you know. So there's technically 4, but technically 5 points that you need. I call this technically 4 because technically you only need 1, 2, 3, 4 because 2 pi and 0 are the same thing. So you need 4, but technically 5 points. 3 of those points are on the midline. 1 is above, 1 is below. Now, how do you know what this is? This distance right here is your amplitude. Okay, so this is your amplitude. Now, your amplitude is the distance above and below your midline divided by 2. So the way that I like to define amplitude is the distance above and below your midline. That's an M. Okay, so amplitude is the distance above and below our midline. So let's go ahead and start to analyze this, okay? So now sometimes you're going to notice that there's going to be a, let's call it y equals a sine of x. Now a, it's the same thing here. A represents your amplitude. And then sometimes you'll see plus k, or I think b, you'll see a b. So A is your amplitude, and then B is what you use to find your period, okay? So B is used to find your period. It's the number in front of X. So use to find period. So to find the period of your function, you're going to say 2 pi. We know that for a sine wave, it is 1 full rotation is 2 pi. And you're going to divide that by B. That is super important. Now amplitude, we're going to do the absolute value of A. And again, that's the distance you're going above and below your midline. Now let's go back to here to our parent function. We don't have an A, we don't have a B technically, but technically we do. So let me write that in. Because we don't have anything in front of sine, I have a 1. And we don't have anything in front of X. I mean, we have sine in front of X, but we don't have a numeric in front of X. We have a 1. So our amplitude is 1. So we have a distance of 1 above the midline and a distance of 1 below the midline. Our B value is 1, so we say 2 pi divided by B. So 2 pi divided by 1 is 2 pi. So we have 1 period is 2 pi. And then we can cut that in half, and have our sine wave, our parent function sine wave. Okay, this section has been reviewed. Now let's go ahead and start with our transformations. Now for transformations, I'm going to show you two things. I'm going to show you the way that we are expecting you to do it, and then I'll show you a different way that also works. But just know that it works, but we're still going to be focusing on the way that we're doing. Okay. So what we have is f of x is equal to a times sine, and I'm putting that times for a reason, sine of b times x minus h plus k. Now, if you had me for semester 1, we're doing trigonometry in semester 2 and IM3. So if you had me in semester 1, we first started transformations and translations. We discussed the importance of the transformation translations all throughout the semester, that you have to know what every single thing is. And this is another great example of you using prior knowledge and applying that. So for A, we already know that's amplitude. For B, we know that it is your period. So 2 pi divided by B is your period. Now H is same thing it always was. That is your horizontal shift. And then your K, again, we always know what this is. So H is your horizontal shift. And then just to recall, for H, it is only this right here. So always think of, if you see like a negative number, think opposite. So if you see like a -5, it is a +5. If you see a +5, think opposite. It's going to be a negative. It also goes in the opposite direction. So if you see a negative, you're not going left, you're actually going right. And then if you have a positive, you're not going to the right, you're going to the left. So think opposite when you think horizontal shift. Okay. So now we have our definitions or translations, and then let's start out with an example. All right, so for an example, let me actually find one here. I have all sorts of examples, but not the ones that I am wanting to do. There we are. All right, so let's start with this example here. We're going to start with -2 sine of x minus pi, and let's call that equal to f of x. Okay, this is where I'm going to start showing you 2 different ways of doing it. I might just do that one time to prove to you that these are the same thing. But again, in our class, we are going to be using the factoring method. You notice here, B is factored out of your horizontal shift. It's also factored out of X, and so we will be doing that, okay? I might not show you in this example since our B, if you notice here, our B is 1. The number in front of X is 1. So that doesn't really change. But in our next example, I will show you how to do that. All right, so step number 1 is identify where your midline will be. Let me actually use a different color. And your midline is going to be your K value. So midline is equal to y equals K. Now it's not an asymptote, it is your midline, y equals K. So whatever your K value is, you're going to do that. So let's actually do this step by step. So here is my x-axis, here's my y-axis. Okay, identify the midline, y equals K. Our midline is, do I have a K value? I don't have a K value, so y equals 0. So that means my midline is still on the x-axis, and that is okay. For your midline, draw a dashed line. It will help you to sketch this out. Just remember that your dashed line is not an asymptote. it is your midline. Okay, so identify where your midline is. Check. Step number 2, let me keep the colors the same. Identify asymptote. And your asymptote, again, is your absolute value of A. So our absolute value of A is 2. So my asymptote, let's keep colors the same. So that means from my midline, I go up 2 and I go down 2. And again, draw some dotted lines here. And we're kind of boxing this in to show where the min and the max values will be, where the height and then the lowest part of the wave will be. All right, so we identify the midline, we identify the asymptote. Next, we need to identify what our period is. So step number 3, identify your period. Again, period is 2 pi divided by b. Now, your number for b in this one, let me show you. This is a of sine times b of x minus h plus k. Let me put that in a bubble. So we know a is 2. We know, what do we know about b? Well, we're looking at the number in front of x that's been factored out. Specifically in our class, we're factoring these out. So we're looking at the number of b that has been factored out. Since the number of b, we're looking at the number in b in front of x is not there, we fill it in with a 1. And then if you factor out a 1, nothing really changes. So we know that our period is going to be, the colors the same, 2 pi divided by 1, which is just 2 pi. So we have identified our period, and our period is going to be 2 pi. From here, okay, from here, we are shifting. Again, what are we doing? We are shifting. We are horizontally shifting to your right pi amount. So again, whatever you see here, you see a negative pi, you really have a positive pi as your h. So what is your h value? Is pi. So once you identified your period, step number 4 is identify your horizontal shift. And so your horizontal shift is your h value. And then step number 5, I'm kind of running out of room. Apply your horizontal, your h, to your period. Okay, so you've seen me identify what my h is. My h is pi. So what's happening to it? We are shifting to the right pi times. So if this originally, if my period is 2 pi, I know that from my beginning to my end is going to be pi. And I think I said from my beginning to my end is going to be pi. So from my beginning to my end is going to be 2 pi, but where am I starting? I'm going to start at pi, okay? So let me go ahead and get another sheet of paper, and so that way we can continue with our steps. All right, beautiful people, I took a moment to redraw this on a separate sheet of paper so that way I can continue with our steps. Now I want to clarify something where step number 5 says is apply your horizontal shift to your period, I can spell. When I say apply your h to your period, this is what I mean, okay? So I want to apply your h I almost want to put a period there and then write that in step number 6. So apply your H. Okay, what is our H? We determined that our H was pi. So I know that I'm going to start my sketch at pi. So let's say pi is around here. This is one of those reasons where I don't want you to use pre-given graphs because you can make this as big or as small as you'd like. You can write in your own increments, and that's much easier than using something that is predetermined. So if this is pi, this is negative pi, and this is, okay. So I'm gonna draw a vertical dashed line here at pi. I know that's where I'm starting. Now I need to figure out where I'm ending. So this is where, let's do number 6. So step number 5, we changed step number 5 to apply your H. Then step number 6, so this is step number 5 is apply your H. Step number 6 is apply your period to your H. And what I mean by that is I know my period is 2 pi. So what is 2 pi from this original starting point? So it's 2 pi from the starting point. So period is 2 pi from the starting point, and this is only for this example. Use your B value to find what your period is for each individual question. So period is 2 pi from the starting point. So that means 2 pi from pi. So if I start at pi and then I go 2 pi from pi, where will I end up? So I'm just going to say 2 pi plus pi, and that I'm going to end up at 3 pi. So if this is pi, I'm just going to give it a sketch. This is 2 pi. This is 3 pi. So I'm going to, again, box in where your ending is. Okay. So let's do step number 7 is mark off your ending. I don't know if that makes sense, but what I mean by that is mark off your ending here. So you have your starting, you have your ending, you have your min, you have your max, you have your midline. So basically now what's left is to sketch. So let's do number 8. Here's where number 8, I want you to look if your function is positive or negative. So that changes. Remember, if it is positive, we have your standard. It's going to look identical to your parent function minus the translations, transformations. Now, if it is negative, you have a reflection across the x-axis. So I'm looking at my original. My original is negative 2 times sine of x minus pi. So then my function is negative. So then I'm going to reflect across the x-axis. So what does that mean for our points? So our original points, remember in the beginning of the video, I said there are 4, but technically 5 points that we need to know. 3 of those points are on the midline. 1 is above, 1 is below. So if we reflect our 3 midline points, so 3 midline, 1, 2, 3. If we reflect them across the x-axis, they are already on the x-axis. There is nothing to reflect there. So you are done. So now you are only reflecting your points. So these 3 points don't change. So you have 1, 2, 3. Now, you need to know where the middle is. So I need to know what this is, okay? I obviously know that this is a pi distance. This is a 2 pi distance. This is a 3 pi distance, but I need to know what is between pi and 2 pi. And I need to know what that is. And I'm honestly thinking in my head the unit circle. So what is between halfway between pi and 2 pi? And that's 3 pi halves. Now I'm actually going to take that a step back because I know that in my unit circle this is pi halves. So then it kind of makes this it easier to find what this value is, but you don't have to. Another way to think about it is I'm going to subtract. So 2 pi minus pi is pi, and then I'm going to divide that value by 2. So I have pi halves, and I'm going to add it to this value. So what I did here, take your 2 points, so 2 pi minus, well, you can't really see that, can you? Let me zoom in. We're saying 2 pi minus pi, that is pi. Take that and divide it by 2, and then add it to the smaller one. And that is 3 pi halves, and that is what we're writing up here. Again, you can take it back and find out what this increment is and add it, but you don't have to do that. So let's do it again. We're saying 3 pi minus 2 pi. Again, you don't have to do this step because we already know that we're going to be adding 2 pi to it. But if you have chosen two different ones, still works the same. So 3 pi minus 2 pi, that's pi. Take that pi, divide it by 2. And this value, simplify it if you need to. This value you're adding to the smaller one. So now we have 2 pi plus pi halves. So that means this is divided by 2. This is multiplied by 2. So 4 halves. So 4, 5 pi halves. Okay, so now we know our 3 points that are on the midline. We have one that's above, one that's below. So if it was a regular positive sine wave, then you would have a point at your maximum, and then you'd have your point at your minimum here. So first comes the maximum, then comes the minimum. Because you have a negative sine wave, you're flipping it, you are reflecting across the x-axis. So my point would have originally been at positive 2. Now I'm reflecting that across the x-axis. I have a negative, so I'm going down to negative first, and then I'm going up to positive. So now that I have my 5 points, I get to sketch and connect. Again, if you can do this in one smooth motion, go for it. I cannot. And again, you cannot give me pointy edges. Can't be. It's a sine curve, sine wave, so it has to be fluid. It has to be. All right, there it is. There it is. All right, let's do more. Before I continue, I do want to head over to Desmos and just show you a few things. So how do you know if you're doing your work correctly? Let me see if I can head over to Desmos here. There it is. You're going to go over to Desmos and you're going to graph this function. So what I did is I graphed negative 2 sine, just exactly what you see. And it did not originally look like this. So what you have to do is you have to go up to your settings, make sure that you have your settings in radians, and then for your x-axis, type in your unit of measure. So for example, I know that my x-axis, you can start it from wherever you need to start. I do like to see a little bit of the negatives. So I have negative pi here. And then here, I know that my function goes up to 3 pi, so I'm going to say 4 pi. And then this is super important. You want to know your steps. So how are we jumping? And that's the number that we divided by 2 by. So we did 2 pi minus pi divided by 2. And that was pi halves. You need to write this in. And how do you write it in? I'm literally typing pi and then pi, and it converts it to pi. And then I'm doing divided by 2. And then you just click anywhere outside and that's going to show you. So This is how, it doesn't look like this, does it, Miss Romanius? No, it does. So we start at pi, so here it is. We have our second point, we have our third point on the midline, we have our negative, right, our reflected point, we have our reflected point. So all of these values should match what you have. Now notice that it is a continuous function, so it continues all the way throughout, all the way throughout. So I can zoom this as much as I want. It is a continuous function, but we don't want that. So we want to just see if our answer was correct, if our numbers here on the x-axis, if our increments are correct as well. Check that, check your wave, check your min, check your max, and then this is how you check your answer. All right, let's go ahead and do number 2. Let's go ahead and continue with number 2. Ooh, that's not what I want. This is what I want. Okay. There we go. Let's start with number 2. I'm going to actually use a different sheet of paper so that way I can use all of my steps and have them in front of me so we can follow along with their steps. All right. Let's see example number 2. Hello, beautiful people. I'm just chiming in here to let you know that example number 2 is going to be in a different video for the sake of shortening this video since it is already on the longer side. So go ahead and head over there. The link should be in the description down below. Thank you again for watching, and I appreciate you liking, sharing, and subscribing to my channel. Go ahead and head over to example number 2 now. Thank you.